This is chapter 28, talking about head and spine injuries. So we've already talked about the nervous system quite a bit, but just kind of a run back over relatively quickly. So obviously the nervous system has nerve cells, and it basically enables the entirety of the body to function. It includes the brain, spinal cord, and then all of the different nerves that run out through the body. Nervous system is relatively well protected. It's got the skull that protects the brain, the spinal canal in the center of all of the vertebrae protect the spinal cord, and there is the fluid, cerebral spinal fluid that all floats in that protects as well. But you can get some pretty serious injuries despite all of that protection. The nervous system is divided into two overall parts. You've got the central nervous system, which is the brain and spinal cord, and then the peripheral nervous system is that massive network of nerves that are not included within the spinal cord. So we've got sensory that comes up to the brain, which then the brain integrates, is what it's called. And then it sends a motor impulse back down through the spinal cord out to one of the peripheral nerves that causes your body to do something in response to it. It's just kind of the general path. Sensory goes up, motor comes down. The brain itself controls the entirety of the body, also consciousness, all of our biologic functions. The brain is divided into three major areas. So you've got the cerebrum, the cerebellum, and then the brainstem. And yes, these are very loose terms. We don't need to go too far into it for this class overall. So here's kind of how it looks. You know that each portion of the brain out of those three are continued to be divided down into more specific areas. Your cerebrum controls a massive variety of activities, including most of your voluntary motor function, and then also your conscious thought and memory. Your cerebellum coordinates balance and body movements, helps you have fine control over the movement that you're doing. And then the brainstem has the majority of your biologic function control center. So your cardiac and respiratory control center, and then of course conducts all of those brain nerve activity down to the spinal cord itself. Spinal cord is a continuation essentially of your brain. The fibers come from the brain's nerve cells and then transmit out to the peripheral cells, nerve cells in the body. You have some protective coverings over the brain, more than just the skull itself and the vertebrae. You actually have several different layers of tissues that are called meninges that end up covering. There's three different layers. You've got the outer layer, which is called the dura mater, literally translated to tough mother, very tough and fibrous, and it contains the central nervous system within it. Then you have two other layers within. You've got the arachnoid mater, which you can see here depicted by kind of that light coral type color, because it does look like spider webs, essentially. And that's there in the middle. And then right on top of the brain itself, you've got the pia mater, which is the most fragile of the different layers. You have cerebral spinal fluid that's produced in a chamber inside the brain. It's called the third ventricle. Its primary job is to act as a shock absorber. But when an injury ends up penetrating the protective layers, then you may see that start leaking out. And there actually is a test that you can do to determine if that is cerebral spinal fluid or if it's something else that you've got leaking. For your peripheral nervous system, you have 31 pairs of spinal nerves. Obviously, you have a left and right side of the body, and so you've got one going to the other. They conduct impulses from the skin and other organs into the spinal cord. So that's sensory information coming up into the spinal cord and then up to the brain. And then you've got motor impulses coming the opposite direction from the brain down the spinal cord and then out to the peripheral spinal nerves. You have 12 pairs of cranial nerves, which don't have that go between of the spinal cord. They actually integrate directly from whatever organ they're associated with, straight up to the brain, or from the brain to that specific organ. Here's kind of a quick look at the peripheral nervous system, how all of those nerves end up coming out. I've mentioned it a couple of times now, but there's two different types of peripheral nerves. You've got sensory nerves, which carry just sensory information from the body up to the brain. And then motor is the exact opposite, carries from the brain out to the muscles to make something happen. You also have connecting nerves, and these are found only in the brain and spinal cord. They connect sensory with motor nerves, and they have very, very short fibers. So they allow the exchange of simple messages. And what these typically do is controls your reflex arc. Because if we need to pull our hand away from a burning stove or a hot stove, we don't want our brain to have to think about it for even more than a millisecond. We want our body to feel that and then immediately react. So what does the nervous system do? Pretty much controls all of the body's activities. We've got the reflex, which we'll talk about in the next slide. We've got voluntary activities, so those which you can consciously perform, you have conscious control over. And then you've got involuntary activities, which are not under conscious control. So these are things like breathing, your heart beating, that keep you alive, that you can have some influence, but not truly conscious control. We've got connecting nerves in that spinal cord, like we were just talking about, that has the form a reflex arc. If your body detects something that could be harmful, if you don't react to it right away, then it's going to cause you to react without it going up to the brain. Now, that signal doesn't necessarily just not travel to the brain at all. It does. You can process what has happened, but it will be typically after you've already responded to it. You've got two different divisions, main divisions of the nervous system. You've got your somatic, which is that voluntary, often just runs to skeletal muscle. And then you've got the autonomic nervous system, which handles all of your involuntary body function. Your autonomic is further divided into two more sections. You've got your sympathetic and your parasympathetic. Sympathetic is fight or flight. Parasympathetic is rest and digest. For the skeletal system, you have the skull, which is composed of the cranium, which protects the brain, and then all of those facial bones. You've got that massive hole down at the bottom where the spinal cord comes out. It's called the foramen magnum. There's 4 major bones that make up the cranium, and then your face is comprised of 14 different bones, and they're listed here on the screen for you, just as kind of a review. The spinal column itself is what gives us our ability to stand upright, helps with our posture. There are 33 total vertebrae that are divided into 5 different sections. You've got different parts to those vertebrae. You've got the bones at the back that forms your bony arch that you can actually feel, and that's called the spinous process, but we don't need to go that far into it. And then you've got a pretty solid rounded portion called the body, and those body portions are separated from each other by cushions called intervertebral discs, and then they're connected to one another by ligaments that do allow for a little bit of motion. Here's the different areas. So you've got 7 cervical, 12 thoracic, 5 lumbar, 5 sacral bones, which are fused together by adulthood, and then your coccyx or your tailbone. For head injuries, these may result in several different types of injuries. It could be soft tissue, it could be bony structures, or the brain, depending on how the force is transmitted. Head injuries overall account for more than half of all traumatic deaths, and those fatal injuries generally involve the brain as well. Keep in mind that even though the head is our main concern when we're talking about certain mechanisms of injury, that doesn't necessarily mean that we don't want to look for additional trauma throughout the body. Truthfully, there's not a lot we can do in the field for head injuries, but we kind of get tripped up on the fact that, holy cow, there's something wrong with their head. Like, we need to still do a thorough assessment. There are 2 general types of head injuries overall. We've got closed head injuries and open head injuries, very similar to fractures. So closed head injuries, there's been an injury to the brain, but there's no true break or opening to the brain itself. And then open head injuries means that there's some sort of connection between the brain and the outside world. Typically, you're going to see bleeding, some brain tissue, and it's often caused by penetrating trauma, but you can have a pretty severe skull fracture that can lead to an open head wound. Motor vehicle crashes are the most common mechanism of injury. More than 2/3 of people that are involved in MVCs or motor vehicle crashes experience a head injury. Other common mechanisms are assaults, falls, and sport-related injuries. So here's kind of some general signs and symptoms of a head injury. This table 28.1 is included in your book, so I'm not going to go over it a lot right here, but I would encourage you to look over this more thoroughly. Scalp lacerations, they range as to how bad they are, but what really gets you as a provider with scalp lacs is that even just a minor laceration can lead to some pretty serious bleeding, especially in kids. Kids have a lot because they just have a lot of area, but just a teeny little cut can cause just massive, massive amounts of bleeding. So don't rate the severity by the amount of blood loss. Make sure that you get that wound, first of all, get it to clot so that you can stop the bleeding, and then make sure you take a good look at it to truly be able to assess the injury itself, because it's probably not going to be as bad as what you think it is. Skull fractures. This is when you have significant pressure obviously applied to the skull itself. There may be opened or closed, kind of just depends on if there's any injury to that overlying tissue. Injuries from bullets or other penetrating weapons frequently result in fractures of the skull, as well as injuries to other things underneath. Signs of a skull fracture include the head just doesn't appear to be structurally correct. There's something deformed. You can see visible cracks within the skull. Oftentimes you're going to have a pretty significant head injury for that to happen. You might have ecchymosis, or that bruising under the eyes, which are called raccoon eyes, or behind the ear, right over the mastoid process, which is called a battle sign. Battle sign tends to take quite some time to form. So if you see that, they've been hurt for a while. So here's a representation of that raccoon eyes and then that battle sign. We will go ahead and stop here, and we'll talk about the different types of skull fractures in the next video.